38, last problem. On the set of axes below, solve the system of equations graphically and state the coordinates of all points in the solution. What is the solution of a system of equations? Well, the solution to a system is the values of the equations that make both equations true. So it's the points that lie on both curves or lines or whatever it is. So if we're going to solve it graphically, we're going to graph both of them and just see where they intersect, and that's the solution to the system. There's a few different techniques. If you're graphing something, you can always make a table of values, or you can just plug in values of x and see what the y's come out to be, and those will become the coordinates. Let's start with this one. There's also a trick to the first one. This is a parabola. So imagine that this was just x squared minus 3. If you didn't have the minus 2 to deal with, then it would just be a parabola which is concave up and which starts at 0, negative 3 right here. What does the negative 2 do? Well, the negative 2 basically just shifts it, and if it's minus 2 it shifts it to the right, if it's plus 2 it shifts it to the left. So it turns out that the vertex of this thing, instead of being here, it's going to be shifted over to, this is where the vertex is going to be, and it's going to be concave up. If you didn't know this, another thing you could do is you could FOIL this out. I'll do it up here. So you'd get y equals x squared minus 4x plus 4 minus 3, which is y equals x squared minus 4x plus 1, right? If you combine like terms. Then, where is the vertex of a parabola? The vertex is always located at negative b over 2a, which is 4 over 2 times 1, which is 2. So it's located at 2. That's the x-coordinate of the vertex. Then the y-coordinate of the vertex, you've got to plug this 2 back in. So 2 squared is 4, minus 4 times 2 is 8, 4 minus 8 is negative 4, plus 1 is negative 3. So y of 2 is negative 3. So 2, negative 3 is the coordinates of the vertex of this parabola. Well, that's what we just said, right? We said that the negative 3 shifted it down 3 units, and the minus 2 shifted it to the right 2 units, and that's how we got it to be here. Okay, now we have to find some other points on the parabola to find out where it actually is. So let's do 2 or 3 points to the left and 2 or 3 points to the right. So for the same formula, and I'm going to work from here, I want to find, let's just do a table of values. We'll do x and y. And we already found out that 2 corresponds to negative 3. Now let's find out what negative 1, 0, 1, 3, 4, and 5 do. And we can go through this pretty quickly. So if we plug in negative 1, we're going to get negative 1 minus 2 is negative 3, squared is 9, minus 3 is 6. 0 minus 2 is negative 2, squared is 4, minus 3 is 1. 1 minus 2 is negative 1, squared is 1, minus 3 is negative 2. And now you're going to see a pattern. 3 minus 2 is 1, squared is 1, minus 3 is negative 2. 4 minus 2 is 2, squared is 4, minus 3 is 1, and you guessed it, 5 is going to be 3, squared is 9, minus 3 is 6. So this is looking like a parabola, isn't it? We have negative 1, 6. That's way up here. Negative 1, 2, 3, 4, 5, 6. And 0, 1. Negative 1, 1, negative 2. That's here. And 3, negative 2. And 4, 1. And 5, 6. That's our parabola. So let's try to draw this. It's going to be a little choppy, but it's better than me trying to draw curves that never ends well. Okay, so that's our parabola. You can imagine it's a little more curved than that, but okay, and now let's graph the other line. The other one's just a line. It doesn't have anything squared in it. So let's grab some red. Let's work with this guy now. So if we want to graph it, we should probably put it in standard I shouldn't say standard, slope-intercept form, y equals mx plus b. So let's make it 2y. We'll subtract 16 from both sides, equals 4x minus 16, and then divide by 2 on both sides, y equals 2x minus 8. So this line has a y-intercept at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And it has a slope of 2, so it goes up 2 and over 1. So that's a point on the line, 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 and so on. So let's connect these. There you go, that's the line. So the only intersection point is this point right here, which is 3, negative 2. And you can make a table of values for this too, but when it's in slope-intercept, it's pretty easy to just graph the intercept and then go up 2 over 1, and that'll do it. So that's really the only intersection point. We have successfully graphed the system of equations. We graphed both equations, and we found out where they intersect, and that's the solution. So 3, negative 2 is the only intersection point.